So students, now we are going to start our 45 problem assignment for magnetic effect of current. First problem is very simple, but two times they asked in AIPMT 1988 and 1997. You know that unit of magnetic flux is Weber. Weber per meter square is the unit of magnetic field, and Weber per meter square is known as Tesla. So we will go with B option. First, Tesla is the unit of magnetic field. Weber per meter square. Gauss for flux we have unit Weber. Magnetic flux are Weber. Magnetic field Weber per meter square. Flux related to unit area are known as magnetic field Weber per meter square. CGS unit for flux is Maxwell. It is CGS unit. And 1 Weber, important points these are 10 to the power 8 Maxwell. Weber per meter square is magnetic field. So SI unit is Tesla. CGS is Gauss. Gauss means Maxwell per centimeter square. So you can relate 1 Tesla is equals to 10 to the power 4 Gauss. So remember these things. 10 to the power 4 Gauss. So first it was B. Second, it is from 1991. A deuteron isotope of hydrogen. You know that 3 isotopes are there. 1H1, 1H2, 1H3. So 1H2 means atomic number 1, 1 proton, 1 electron, and 1 proton and 1 neutron as mass. Of kinetic energy 50 kilo electron volt is describing a circular orbit of radius 0.5 meter in a plane perpendicular to magnetic field B. The kinetic energy of the proton that describes a circular orbit of same radius in the same plane with the same magnetic field. We know that what was R? We have a complete derivation in our previous slides. R was mv upon q into B. But what was mv? In terms of energy, from mechanics we know that it is 2me. E is energy. Now for this problem, first we make the relation formula. Deuteron and proton both are moving in same radius circle. So they are saying R for proton and R for deuteron both should be same. First we are writing R deuteron. I am writing first this, or I will write this on right hand side because deuteron they gave us. Proton we want to find something. For deuteron, suppose I am taking mass m. Energy in kilo electron volt. I am putting only kilo electron volt so that I need Rp also in keV. It is 50. Charge on deuteron I am taking Q, magnetic field I am taking B. What should I put in place of these physical quantities in Rp? In Rp. C. It is 2. Mass of proton is half of mass of deuteron, because in a deuteron there is 1 proton and 1 neutron. So in place of mass we have to put m by 2. We want to calculate energy. E is unknown. Charge is same on proton and deuteron. Deuteron has 1 proton in its nucleus. B, they are saying same magnetic field. So cancel QB with QB. This 2 with this 2. M with M. By squaring we will get E is equals to 2 into 50 means 100 electron volt. 100 keV. What unit we put for P50? We will get same. So we are going with option D. Next, it is from 1991 AIPMT. A uniform magnetic field acts right angles to the direction of motion of electron. As a result, the electron moves in a circular path of radius 2 cm. If the speed of electron is doubled, then the radius of the circular path will be. What is the formula for radius? Just we write in previous problem, mv by qb. It was initial radius, which they gave 2 cm. What we are going to do now? Same electron is coming, so mass should be same. Speed is doubled. In place of v, I am putting 2v. Same electron, so same charge. Magnetic field is also same, so putting B. So in place of mv by qb, I am writing 2 cm. So now I am getting final radius 2 into 2, 4 cm. So I am going with C. So correct answer was C. Next problem is from 1993. AIPMT. A charge moving with velocity v in x direction is subjected to a field of magnetic induction in a negative x direction. As a result, the charge will remain unaffected, start moving in a circular path, retard along x-axis, start moving along a helical path around x-axis. What is the formula? Lorentz force. Lorentz force was F is equals to QBV sin theta. Electron was moving with velocity in x-axis direction. Field of magnetic field is opposite to the velocity. It means angle between V and B is 180 degree and sine 180 is 0. What was the formula? F was QBV sin theta, Lorentz force. In this case, velocity in positive x-axis direction, magnetic field is in negative x-axis direction, so angle is 180 degree. And we know that sine 180 is 0. So no force. No force means remain unaffected. Fifth problem. A beam of electrons is moving with constant velocity in a region having electric and magnetic field of strength 20 volt per meter and 0.5 Tesla at right angles to the direction of motion of the electrons. What is the velocity of the electrons? We know the formula कि if V and B, electric field and magnetic field, both are given, you can calculate this by the formula velocity is equals to electric field is 20 volt per meter and magnetic field is 0.5. If both are acting perpendicular to each other, in combined effect, velocity of charge is given by E by B. So what was E? E was 20 SI unit. B was 0.5 means 1 by 2. So what we are getting? 40 meter per second. So we are going with D option. Fifth, D. 6. It is from 1996. AIPMT. A 10 electron volt electron is circulating in a plane at right angles to uniform field. 10 to the power minus 4 Weber per meter square means 1 Gauss. I told you that 1 Tesla Weber per meter square means Tesla is equals to 10 to the power 4 Gauss. The orbital radius of electron is, all options are in CGS unit, but better to solve initially in SI unit, convert lastly in CGS. So no chance of mistake. What is the formula for radius? Basic formula was mv by qb, but they are giving us energy. So what we have to write in place of mv? 2 me divided by qb. So now we are going to solve in SI units. Two, mass of electron 9.1 into 10 to the power minus 31 kg. Electric field 10 electron volt. I am converting in joule. Joule means 1.6 10 to the power minus 19 divided by qb. Q charge 1.6 10 to the power minus 19. B 10 to the power minus 4. So what numbers are in numerator? First we are solving them. First calculate the zeros. Remove this decimal with 1 0. Minus 31 and minus 19. Minus 50. Take 10 to the power minus 25 outside the square root. From 16, 4 is outside the root. From 9, 3 is outside the root. In square root, only root 2 is there. In denominator, 1.6 into 10 to the power minus 23. It is in meter. So multiply by 100, so you will get centimeter. Minus 25 and 100 means minus 23. Cancel this with this. Remove this and multiply numerator by 10. 4 4s are and 4, you will cancel this 10, you will get 2.5. 2.5 into 3 it is 7.5. Root 2 means nearly 1.4. So what we are getting, 14 5s are 70, carry 7, 98 and 7, 105. 10.5, little bit greater than this. So we are going with 11 centimeter. So sixth we got option A. Seventh, it is from 1997 AIPMT. A positively charged particle moving due east enters a region of uniform magnetic field directed vertically upward. This particle will move in a circular path with a decreased speed, move in a circular path with a uniform speed, get deflected in vertically upward direction, move in circular path with increased speed. I give you concept of that Lorentz force. If particles are coming at right angle to magnetic field, with same speed, they will start moving in a circular orbit. The force will provide them required centripetal force. So speed should be constant and will move in a circle. So we are going with B. It is from 1999 AIPMT. A charge having E upon m, it is known as specific charge, equal to 10 to the power 8 coulomb per kg, and with velocity 3 into 10 to the power 5 meter per second, enters into a uniform magnetic field B 0.3 Tesla at an angle 30 degree with direction of field. The radius of curvature will be, we know that what is the formula for radius? mv by qb. What you need? You need m by q. You need v, you need b. First we will solve in SI units. Last we will convert in CGS. They gave charge upon mass. We need mass upon charge. So revert this. It will be 1 upon 10 to the power 8. Velocity 3 into 10 to the power 5. What is B? It is 0.3 Tesla. But angle is at 30 degrees centigrade. So force will be QBV sine theta, which will provide, now what will happen? QBV sine theta. It will provide centripetal force mv square by r. So R will be in sine 30 means 1.5 should be there. 0.5 sine 30 1 by 2. 0.5. So 10 to the power 5. 8 zeros we have in denominator. 2 we will use to remove these two decimals. 5 we will cancel with this. In centimeter we will multiply by 100. So what we will get? 5 and 2 7 0. 7 will cancel with this. 1 will remove the decimal. 3 will cancel with 3. So what we will get finally? 10 by 5. 7, 7. 1 I remove with decimal. When we will remove this decimal, you will get 1 0 again in numerator. So we are going with 2 centimeter. means D option is correct. So 8th D option. So remember this. What force is acting on charge? It will provide the centripetal force. So means if theta is 90, then only learn mv upon qb. It is general formula, but remember in your mind at time of derivation, when we were doing this, charge enter at perpendicularly to the magnetic field. That's why we didn't take this theta. But in actual practice, we will take this sin theta. So this type of problem you will not confuse. Next, it is from 2001 AIPMT. An electron having mass m and kinetic energy E enter S in uniform magnetic field B perpendicularly. It is important. Perpendicularly means we can use our formula R is equals to mv by qb. Now we can use this. In terms of kinetic energy, we can write mv. An electron having mass m, kinetic energy S, E enters in uniform magnetic field B. Mass is m. Kinetic energy E means it should not be there. In uniform magnetic field B perpendicularly, then its frequency will be. We know that what will happen when charge will enter the magnetic field. That force QBV will provide centripetal force, and we get this relation for R. So we can calculate V. Lastly, we will convert in E. First, we are getting the result for frequency. What we need for frequency? V is equals to. We can calculate with the help of this relation also. In this relation, it is QB R by m. But speed is equals to distance upon time. In one cycle, it will complete its whole circumference. If its time period is t, we can write this QBR by m. So cancel R with R, no need for this. And 1 upon t is frequency. So what we are getting? Frequency into 2 pi is equals to QB by m. No space for energy now. Frequency is independent for that. If mass is given, no need for energy. We get QB by 2 pi m. QB by Q is E. EB by 2 pi m. So we are going with C. 9th question, C answer. 10th, a charge Q moves in a region where electric field and magnetic field both exist, then force on it should be. It is from 2002 AIPMT. What they are saying, electric field is there. What they are saying, magnetic field is there. We know that electric field means force experienced by unit charge. If Q charge is there and field is E, force should be Q into E in the direction of electric field if charge is positive. And for magnetic field, it is Q into V cross B. So if both are there, then both force should be there. So QE plus Q into QE plus Q into. So it should be, now both options are there. B cross V and V cross B. So actually it is V cross B. Actually it is V cross B. So take care of this. when a charge is entering in a magnetic field, it will experience a force. Now we are going to solve problem number 11 from 2003 AIPMT. A charged particle moves through a magnetic field in a direction perpendicular to it. Then the speed of particle remains unchanged, direction of the particle remains unchanged, acceleration remains unchanged, or velocity remains unchanged. Again a repeated problem. Particle will start moving in a circle with uniform speed. Since moving in a circle, velocity cannot be constant. Acceleration at every point is acting towards the center. So at every point its direction is changing. So velocity cannot be constant. So only speed is constant. So we are going with A. Next, an electron moves in a circular orbit with a uniform speed v. It produces a magnetic field B at the center. The radius of the circle is proportional to. We know that when a particle will enter in a circular orbit with uniform speed b, what will happen? You know that for circular orbit is behave like a circular coil. And if number of turn is 1, what is the formula for B? Mu naught Ni divided by 2R. We have a complete derivation in theory slides. Mu naught Ni by 2R. But what is I? I is Q by T. So what we are getting? If charge is, I am taking Q, it is Q by T into 2R. What is time period? It is Q by T. Suppose time period I am writing here T. T, you know that if particle is moving in a circle, in one time period it will complete one cycle. If time period is T, in T second it will cover a distance of this 2 pi R. If its velocity is V, you can write V 2 pi R divided by T. So you can replace T by 2 pi R by V. You can replace T by 2 pi R by V into 2R. So what we are getting? Take V in numerator, mu naught Q V divided by 4 pi R square. So what we are observing here? R square is equals to mu naught QV divided by R square is equals to mu naught QV upon 4 pi B. So we want to check radius relation with V and B. So it is very clear now. R is proportional to square root of V by B. So we are going with option C. Next, it is from 2006 AIPMT 13th problem. When a charged particle moving with velocity V is subjected to magnetic field of induction B, the force on it is non-zero. This implies that we know that when a charged particle will enter in a magnetic field, it will experience a force which is QBV sin theta. What is force? Force is Q Lorentz force, B V sin theta. So force can be 0 if velocity is 0, but velocity is not 0 here, it is given V. It is charged particle, Q cannot be 0. Entering in a magnetic field, B is not 0. So now, which term can make F 0? Only sin theta. And sin theta is 0 if theta is equals to 0 or 180 degree. So we are going with option D. Means 0 and pi, only two angles can make force 0. If force is non-zero, any value you can give between these two angles, because sine 0 degree is 0 and after that sine 180 degree is 0. In between these two values, sine has a non-zero value and QBV all are non-zero. So for non-zero value, now we can take any angle between 0 and 180 degree. Next, it is from 2007 AIPMT. In a mass spectrometer used for measuring the masses of ions, the ions are initially accelerated by an electric potential V and then made to describe semicircular path of radius R using a magnetic field B. If V and B are kept constant, the ratio charge on ion means Q upon M will be proportional to. So what we are knowing? We know that R is equals to MV by QB. They are saying we are putting V constant. V constant means we are putting energy constant. So first I am converting this into energy. So we can multiply numerator and denominator. We know that what they are saying, what is energy? Energy is half mv square. But this energy we are supplying to electron with the help of potential difference E into V. So if we want energy constant, means half mv square should be constant. We want relation between R. The relation of V and B are constant, charge on the ion and mass of that. So half mv square is the energy. So multiply and divide this by V. You will get this mv square upon VQB. Half 2 into half. We are introducing that energy mv square divided by VQB. This half mv square is constant. This is constant. So we are putting K for this. 2K upon V into QB. So now we are going with the relation R is mv upon QB. Or we can put this, because in this there is no M now. So we can use V from this to that relation. R is QB mv by QB. So we will use this V, R QB by M. We will use there. So half M V square means R square Q square B square divided by M square. E into V means charge we are taking by Q into voltage. So now we will get the relation, cancel with M, Q with Q. Now take charge and mass on this side, Q upon M. All remaining things on second side. So this 2 I am taking there. V is already there. R square in denominator. This B square in denominator. They are saying B is also constant. V constant, 2 constant, B square constant. It means Q upon M is proportional to 1 upon R square. So we should go with option A. So we are going with option A. It was from 2007 AIPMT. 15th, it is again from 2007 AIPMT. A beam of electron passes undeflected through mutually perpendicular electric and magnetic fields. If the electric field is switched off, it means only magnetic field is there, and we know that if a charged particle is entering into a magnetic field, what it will feel? It will experience a force, Lorentz force, and it will start moving in a circle. So it will start moving in a circle. So we are going with option A, Lorentz force. Next, it is from 2008 AIPMT. A particle of mass m, charge q and kinetic energy T enters perpendicularly in a magnetic field B. After 3 seconds, the kinetic energy of that particle will be. So in so many previous problems, we have discussed that when particle is entering into a magnetic field, it will experience a Lorentz force and it will start moving in a circle with uniform speed. If speed is uniform, kinetic energy should be same, half mv square. So after 3 seconds, 4 seconds or 8 seconds, it should be T only. So we are going with A. Next problem. It is 2 times they asked in 2007 and 2009 AIPMT. What they are asking? The influence of under influence of a uniform magnetic field, a charged particle moves with constant speed v in a radius r. The time period, we have derivation. What we discussed in previous slides, r is mv by qb. Now our purpose is to introduce time period. We know that in one time period, particle is traveling a distance equal to the circumference of the circle. So its velocity should be distance upon time, 2 pi r by t. We can replace v by this. So r is equals to m into 2 pi r. R we are taking capital R, so we will take capital R. 2 pi r by t. So what we are getting? In place of v I put this, and this is q and this is b. Cancel r with r. So what is the formula for time period? 2 pi m upon q into b. So in t, only 3 physical quantity matters: mass of particle, charge of particle and magnetic field. So it is independent of v and r. R is also cancelled out. Next, it is from 2009 AIPMT. The magnetic force acting on a charged particle of charge minus 2 microcoulomb in a magnetic field of 2 Tesla acting in y direction, when the particle velocity is this, is, we know that force can be calculated by the formula q into v cross b. First we will discuss direction. Direction is important. Particle is moving in which direction? See, magnetic force we want to calculate. Magnetic field is in y-axis direction. So direction of B is positive y-axis. Particle have direction this, 2i plus 3j. So we can calculate direction only when we will get this product. So we want V cross B. Cross product means determinant. We have to make one determinant. First row I, J, K. In V, we are getting coefficient of I 2, coefficient of J 3, K 0. And into 10 to the power 6, that is constant, so we are taking outside the bracket. We take common from this row. B, 2 Tesla in Y direction. It means 0I, 2J, Y direction, J, 0K. So what is B? 0, 2, 0. So we are getting V cross B, 10 to the power 6, bracket, coefficient of I, 0 minus 0, 0. Coefficient of minus J, hide this and this, 0 minus 0. Coefficient of K, hide this, 4 minus 0, 4. So what we are getting? 4 into 10 to the power 6 K cap. So 4 should be Q V cross B multiplied by Q also. Q is charge of minus 2 microcoulomb. So if we are taking minus 2 microcoulomb, it will become minus 8 into 10 to the power 6 K cap. So magnitude is 8 into 10 to the power 6. And micro means 10 to the power minus 6 is also there. So minus 6 will cancel this 6. Q is minus 2 microcoulomb. So now we are getting F minus 8 K cap. Minus K cap means negative direction of Z axis and magnitude is 8 Newton. So we will go with D. So we have to take care of direction because both options were present there. 8 Newton in Z, 8 Newton in minus Z, 8 Newton in Y. 3 options were there. Next, it is from 1992. AIPMT. A straight wire of length 0.5 meter and carrying a current of 1.2 ampere placed in a uniform magnetic field of induction 2 Tesla. The magnetic field is perpendicular to the length of the wire. The force on the wire is, it is direct formula, ILB sin theta. Each and everything in proper unit is given. I 1.2 ampere, length 0.5 meter, SI unit again, B in Tesla 2, theta 90 degree and sin 90 is 1. So what we are getting? 0.5 into 2, 1, 1 into 1.2, 1.2 Newton. So we are going with option B. Next, it is from 2000 AIPMT. The magnetic field at the center. Now we know the formula. What is the formula for magnetic field? Mu naught upon 4 pi near a wire, 2I by R. But 2 wires are there. So we have to calculate both magnetic fields with direction because field is vector quantity. Otherwise tough to add. First I am talking about 5 ampere. Put your right hand thumb. So what you are getting? Magnetic field inward. So B1 I am taking to this and B2 to this. So what is B1? Mu naught upon 4 pi 2 I, R is 5 by 2. Inward, so I am putting cross. What is B2? Again I am putting thumb. It is outside the page, outward direction, just opposite direction. So it is mu naught upon 4 pi. 2. I is 2.5. R again 5 by 2 means 2.5. It is outward. So both are in opposite direction. What is B1? B1 is mu naught upon 4 pi. 2 into 2, 4 in inward direction. What is B2? Mu naught upon 4 pi into 2 outward. They are not talking about direction, but we should aware for that. Since inward is greater than outward and both are in opposite direction, so resultant is difference of them and it will get the direction of bigger one, B1 minus B2, and direction should be inward. So what is the difference between B1 and B2? You can calculate. Take mu naught upon 4 pi common. 4 minus 2, we will get 2. So what we are getting? Mu naught upon 2 pi in inward direction. So we are going with C. So 20th C.